In this video, we are going to talk about how heat can transfer throughout a chemical reaction. And in order to do that, we need to talk about thermochemistry. And thermochemistry is a measurement of how that heat transfers in a chemical reaction. And it is generally measured in the form of kilojoules per mole. Kilojoules is a really small unit of energy. So a lot of times, instead of dealing with hundreds of thousands of joules, we just deal with hundreds of kilojoules. Pyrolysis is the decomposition of solid fuels into really small gaseous compounds, and these small gaseous compounds can combust. Now, in order for reaction to even take place, it must meet the activation energy. You can think of it as the minimum amount of energy for a reaction to happen. If you don't meet this reaction barrier, then the reactants cannot form the products. So, when we're talking about how heat is transferred throughout a chemical reaction, we have two different terms to do this. The first is an exothermic reaction. And an exothermic reaction is where heat is released or it is a product and it releases into the surroundings. So, if this is the case, then the energy of the reactants is higher than the energy of the products. And we can use a reaction diagram or an energy diagram to show what this process looks like. Here, my reactants are going to be at a certain energy. And in order for this reaction to take place, they have to get all the way up here in energy. And this is the activation energy, the difference in energy between the reactants and the tallest possible point. Now notice that as soon as it reaches that barrier, then it can drop to the products. So the difference in energy between the products and the reactants, that is the energy that is released. That is the thermochemistry or the heat that is produced by the chemical reaction. So a big thing with exothermic reactions is heat is produced by the reaction. It is a product of the reaction. So fire is a great example of an exothermic reaction. Now, energy can also be absorbed. So an endothermic reaction is where energy must be absorbed in order for the reaction to take place. So in this case, the energy of the products is higher than the energy of the reactants. And notice that our activation energy for an endothermic process is much higher than that of an exothermic process. It's still the energy difference between the reactants and the highest possible point in the energy diagram. And the energy that is absorbed is still the energy difference between the reactants and the products. So in this case, in an endothermic reaction, heat is a reactant. All right, if it's being absorbed, it means it's going into the reaction. A lot of instant ice packs that you have are endothermic reactions.